All right, in this demo, we're going to find out that a moving magnetic field can create a current even if we don't have our circuit hooked up to a voltage. So in this example, what I have, let me show you from the side, what I have is a coil of wire. So it has 350 loops of wire round around a little plastic center here. And the wires are hooked up to my current meter. So it's going to read current. The current can either be in one direction or the other. Okay? So if it's going one way, the needle will move to the left. If it's going the current's going the other way, it'll move to the right. Okay? So right now, just sitting there, we see that there's no current, right? Because we're not hooking it up to a voltage. There's no resistors in here to force the current to go around. Okay? But here I have 4 magnets just wired together to make this effect stronger so that you can see it more easily. And if I change the magnetic field that this coil of wire is in, I can produce a current. Okay, so this is what Faraday found out. So we're going to take this, we're going to move it over by the coil, and remember what a magnet looks like. We'll take a look on the board here. If our magnet has a north pole this way, down at the bottom, south pole up at the top, the magnetic field lines go from the north back up into the south. And remember, where the density of field lines is the highest, that's where the strength of the magnetic field will be the highest. So if I go over here, the strength of the magnetic field would be low. But if I go right here near the ends of the magnet, the strength of the magnetic field will be much higher. Okay? So watch as I move the magnet in. Watch what happens to the current. Let's move that out of the way. So if I start off from far away, no effect. If I go further in, we can start to see a current. If I change the magnetic field quickly by moving really fast, I can spike the current really high. Okay? So if I bring one pole down, it moved to the right and then swung to the left. If I switch poles, now I'm changing the direction of the magnetic field, so it should swing first to the left, and then as I pull the magnet out, it'll switch to the right. Ready? There you go. And pull it out. Okay. Now the faster I move the magnet, the faster the current I can get going in here. Okay, the faster I move it. All right? So moving magnetic field creates a current in a loop, a circuit, that isn't connected to any EMF, no battery, no plugging this into the wall. So this is how your phone charger basically works, an induction phone charger. One of the chargers that basically sits on your desk, and you put your phone on top of it without plugging your phone in, and it automatically charges. What it's doing is creating a time-changing magnetic field that forces the current to move backward through your battery and recharge the battery.